let's suppose you were trying to make s'mores and you had 100 marshmallows, but you only had 10 graham crackers. How many s'mores could you make with those ingredients? Well, we know that one s'more needs 1 marshmallow and 1 s'more needs 2 graham crackers. So with these ingredients, we could make 100 s'mores with 100 marshmallows, but we could only make 5 s'mores with 10 graham crackers. So if I had 100 marshmallows and 10 graham crackers, even though I had plenty of marshmallows, my graham crackers would run out first, so I could only make 5 s'mores. That's where the idea of limiting reactant comes in. The limiting reactant is the reactant that runs out during the reaction, causing no more product to form. So if I have too little of one thing, that means that I have extra of something else, and that's called the excess reactant. The excess reactant is the reactants that are left over after the limiting reactant runs out. Now, in every equation, when we run a stoichiometry problem, we have an answer that we calculate. So we say, oh, we should be able to make a certain amount in grams or a certain amount in moles. But the reality is that in the lab, you can never make how much you think you should. And that's because you might lose some product or miscalculate, or there might be a scale error. For whatever reason, we don't ever make the actual amount that we calculate on paper. The actual amount that we should be able to make is called the theoretical yield. That is my calculated amount of product that can be formed. When that limiting reactant runs out. So in any stoichiometry problem, you may be given 2 amounts of different reactants, and you're asked to find the amount of product that can be produced. So in this case, you need to determine the limiting reactant first and then perform the conversion problems. So to determine the limiting reactant, we're going to convert each reactant into a product, and the reactant that forms the least amount of product is our limiting reactant. Now, it doesn't matter what product you choose. If you have multiple products, just choose one product and convert both of my reactants into that same product, and we'll see which one has the least. So let's look at an example. N2 plus 3H2 yields 2NH3. If I have 5.2 moles of N2 and 13.4 moles of H2, which of those is my limiting reactant? So in this case, I have to set up 2 problems and convert both into NH3. So 5.2 moles of N2. There's 1 mole of N2 for every 2 moles of NH3. And then I have 13.4 moles of H2, 3 moles of H2 for every 2 moles of NH3. 5.2 moles of N2 would make 10.4 moles of NH3. 13.4 moles of H2 would only make 8.9 moles of NH3. So in this case, hydrogen is going to run out. 8.9 moles is the most I can make. So we say that hydrogen is my limiting reactant.